Hello and good evening. I'm pleased to welcome you tonight. We are in the format of Bees Without Borders, format from FreeTheBees, and we have monthly very interesting speakers, interesting themes. And it's more or less all about bees, and we define it in the way that anything that is impacted by bees and anything that might impact bees. So quite a large and broad spectrum of different themes and very interesting speakers. And tonight I'm pleased to welcome Dr. Patrick Kohl. And we just had the same lecture before in German, and as we speak to an international audience and we have different languages in Switzerland, it's for us it's very important to be able to record the same lecture and have you here in English. So Patrick, your theme, I think I'll let present you directly your theme and probably some words on yourself, and very pleased having you here. Thank you for your time.
Yeah, thank you, Andre, for having me. Hello, everybody. Thank you for attending. So, a few words to me. I started investigating wild honeybees almost 10 years ago now, together with my friend and colleague Benjamin Rutschmann. We were among the first in Europe to look at wild living colonies and made the first assessment of their occurrences in Germany. And this led to two PhD theses that we did at the University of Würzburg in Germany. And now I'm a postdoc at the Department of Population Genomics of Livestock at the University of Hohenheim. And if you're interested in our ecological research on the wild colonies, Benjamin gave a talk in exactly this setting. And you can see the presentation, it goes into the details. This time I thought I zoom out a bit and ask the question, what is wildness in honeybees? And I think there are three levels of wildness in honeybees that can be investigated and that are actually being investigated in Europe. And I give a brief overview of what are the research methods, what is our current state of knowledge, and what are the current questions maybe. So as a brief overview, I will talk about wildness on the level of individual colonies, wildness on the level of the population, and then regarding the population level, we have a nice application of this this level for practical conservation issues. And we can also talk about wildness with respect to the evolutionary history of the honeybees in Europe, with respect to the long history of beekeeping management. And then if there's time, I would like to talk about generally why should we investigate and conserve wild honeybee populations and which levels are maybe most important for us. And then end with suggestion to always try to describe a given honeybee or honeybee population using as many variables as possible, because we often have the aim of having the perfect word for what we see, but this rarely really fits. So just the awareness of that there are multiple dimensions you can consider in the context of wildness and honeybees. Okay, so I think this map well illustrates the problem. This is a world map of the original distribution of Apis mellifera, the western honeybee. Yes, this is all Africa, Western Asia, and Europe, and the invasive range, which is pretty much the rest of the world where the climate is suitable. So, beginning in the 17th century, approximately, the honeybee was brought to the Americas and Australia, and a bit later also to Asia for honey production. And yeah, what you see here is this shaded area. Patrick et al. Used to highlight that the European part of the range, we assume that the population predominantly exists of managed colonies. And this is from 2017. I can tell you that this was probably just a conservative wording. What everybody actually thought is that the wild honeybees were extinct in Europe. Why is that? So if you ask any beekeeper or entomologist, even bee researcher, most people will give you this answer. It's the parasitic invasive varroa mite, which came to Europe in the 70s and 80s. And since beekeepers saw that without treatment against the hive, they would have high colony mortality, the logical thinking was that it must have been the arrival of the mite that led to the eradication of the wild honeybee populations in Europe. Sadly, there's really little information on the wild colonies in that time, and generally, it's very difficult to find anything in the older literature. There are exceptions, as always. Frank, like Mr. Stöckhardt, for example. I don't actually know his name. He was a zoologist and he wrote a book about the bee fauna of Franconia, so southern part of Germany, and in 1933. And in this book, he already had a small paragraph about the honeybee, and he already considered the honeybee as extinct, but for a very different reason. He said that it's the loss of hollow trees in our modern forests that are managed for timber production, that's the main reason for the disappearance of the wild honeybee. So this shows us that there's actually no direct information whether the colonies died because of the lack of habitat or because of parasites. And very interestingly, the place where the first studies on wild honeybees were performed is not the native range, but North America. So Professor Seeley at Cornell University, he was pioneering in studying wild honeybees in their natural habitat. And he already did many studies in the 70s and 80s. And that's what most of our information comes from today still. And these populations in the northeastern United States, the large forests, and they became especially famous when Seeley repeated some of his studies in the 2000s and later, after the varroa mite had colonized these areas. And he showed that the bees were still there, the densities were the same, the population is still stable. Obviously, this was extremely interesting. The first study from Europe only appeared in 2013 when Andrzej Oleksa and Adam Tofilski showed that avenues in northern Poland are inhabited by wild living colonies. These avenues, they were investigated to see what's the nature conservation value of these old trees, and in 142 kilometers of rural avenue, they found 45 nest sites. So there seemed to be some pattern. And what we learned from the work of Tom Seeley, but also from this work, is very important. we have to specifically look for wild honeybees to get any information on them because they're not very abundant even under natural conditions, and their nests are often well hidden. So this insight, and especially the finding from Poland, it motivated Benjamin Rutschmann and me to also search for bee colonies in Germany. And that's where we are starting. The first level of wildness in honeybees is the level of the individual colony. So we have to consider, or we can easily consider the current state of living, so to say, of a honeybee colony and pretty clearly distinguish managed from wild living or free living colonies. These terms can be used interchangeably. I also would argue that when you talk about colonies, you can always talk wild colonies, say wild colonies, but of course um, it's a bit safer to say free living or wild living colonies, then it's clear that you're referring to the current situation, the current state. And an easy definition of wild living colonies is the one presented here. It's colonies that have chosen their nest site independently and are not cared for or not disturbed by humans. Of course, there are some gray zones when there's an abandoned apiary nobody's looking after, and a swarm moved into one of the bee boxes. Then you maybe have to ask first whether anybody is managing these bees. When you find out they're not managed, then it's also a wild living colony. And the simple leading questions on this first level of wild honeybee research is, in my region or in the region I want to consider, do wild living honeybee colonies exist? And if so, how many? So the question of distribution and abundance. And yeah, I would like to present some methods that were used, give an overview of what is our current state of knowledge here, especially in Europe. So the method to go is the beelining method, where honeybees are caught on flowers. So foraging honeybees are usually easy to find. They're caught on flowers with a beelining box, and within the beelining box they're fed an artificial sugar solution and a piece of comb. And then they are released, and you hope that the bees prefer your artificial food over the reward by the flowers. This actually pretty much always works in summer, late summer, when there's not much nectar production in the landscape. And yeah, the bees come back. You can paint them individually to distinguish them, and then based on the direction of flight and the round trip duration, nest feeder, you can make estimates of where the nest is. This is nice because it's a pretty unbiased method to assess densities and find nest sites in different habitats. This here shows maybe the oldest map produced by beelining technique by Tom Seeley and his colleague Georg Fischer. Shows the Arnott Forest, and here you see these triangles were the feeder positions. These lines are the flight directions of the bees, and based on the flight directions, the team was able to map some colonies that are denoted here as circles. And nicely also show that the filled circles are the ones they in the end really managed to find exactly. And in this study system, Seeley repeatedly reported a colony density of about 1 colony per square kilometer. Benjamin and I also used this method in the Hainich National Park in Thuringia. Here's our result. We have the feeder stations here. It's the blue asterisks, and the bee lines according to the flight direction and round trip duration of the bees. and the places where we expected wild colonies in the forest. And in this study system, we estimated one colony density of only 0.13 colonies per square kilometer, but we were really able to say these colonies occur in this conservation area. A different method that has been used is the specific inspection of potential nesting sites. So a selection of potential sites beforehand. Again, the example of the rural avenue in Poland. And we also did something like that in a different study area on the Swabian Alp. We inspected cavity trees of the black woodpecker that were known before and that we suspected or assumed that they would be suitable nesting sites for honeybees. And with these methods, we interestingly found a similar density of colonies than with the beelining method in the different forest. In another study in Spain, we also used this method of looking at specific sites, and we used these hollow power poles, which was quite successful in this agricultural landscape where we thought there are not many other nesting sites. Of course, when you consider to look at a certain type of nesting sites, there's always a bias. You will miss many colonies that nest at different sites, but under certain circumstances, this can be useful, especially if with this method, you usually find many colonies in a short time. Another method, a third method, which was perhaps used most so far in the European studies, is citizen science. So just asking people for help. And this is the nice study by Benjamin, Felix Remter, and Sebastian Roth, using the data from the bee tree monitor that was collecting sightings of nest sites of wild honeybee colonies over 7 years in Germany. The nice thing is you get infos over a large area. Problem is, because the area is large, it's difficult to investigate the colonies further. And we also have to consider slight bias, reporting bias. So here are the different landscape types in Germany: urban areas, grassland, cropland, deciduous forest, coniferous forest. And these dots, they show the overall proportion of these landscape types in the country. And the bars shows where do the colonies nest that were found. And even if we can assume that in cities there are many wild living colonies because there are also many beekeepers, there's certainly some bias. People are more likely to find colonies that are near their homes, obviously. Yeah, and since 2023, there's a really nice study out by Olli Weissig and Francis Radnieks. It's a meta-analysis of all available studies on the density of colonies, also including studies from Europe. They were able to include into their analysis data from 41 locations worldwide. And these are the results for the estimate of colonies per square kilometer for different continents. I see here that Europe has the lowest density of wild living colonies, but we can assume that there's about 1 colony in 4 square kilometers in Europe. This figure is also pretty interesting because it shows the density of wild colonies in relation to the density of managed colonies. The managed colonies here in the darker bars and the wild colonies in the lighter bars. And this nicely shows that when you take a global perspective, there's really no reason to say the honeybee is a completely managed species or even domesticated species. Just by numbers, there are many more wild colonies than managed colonies. The exception is Europe, Here we have many more managed colonies, and the share of the wild colonies is about 1/6 of the total population. So this is the state of knowledge for the level 1, the colony level. Are there wild colonies and how many? Of course, when you see such an image, the bees, it looks that it's totally normal for the bees, but everybody would ask, are these really wild colonies? And the level more relevant, maybe on um, the more relevant level of wildness in honeybees is the population level. So I think it would be common sense if there's a self-sustaining population of wild living colonies, that this population can be considered truly wild. And the leading question is, do the wild living colonies we find in our study region, do they form a self-sustaining population? So the thought experiment, were all the managed colonies gone, would the existing wild living colonies be able to account for colony losses by swarming? And yeah, it's really important to zoom out and to really consider the population perspective here. Because in beekeeping, we're a bit biased. We typically assume that a colony is practically immortal. So the bees change their queen, and beekeepers also remove old wax combs, replace them with new wax foundations of empty frames. We feed them, we treat them against parasites. So many beekeepers would like to have their, let's say, 7 colonies, and these 7 colonies should always survive the winter. 100% survival is the goal, but they shouldn't reproduce, so should stay 7 colonies. In nature, obviously, it's normal that organisms die, and but it's also normal that they are able to reproduce. And the nice thing is when we look at the population level, we don't need individual wild living colonies to be immortal or live very long for the population to be stable on its own. And to analyze the population status, it's helpful to look at this figure to see what are the variables in the system. So we can consider that there's a regional honeybee population consisting of a subpopulation of managed colonies and the subpopulation of wild living colonies. And the size of the wild living subpopulations, on the one hand, depends on the migration. So colonies from the managed subpopulations can migrate into the wild living population in spring when they swarm and beekeepers fail to prevent the swarming. So they become ownerless, search for a cavity, and become part of the wild living group. And this migration can also go into the other direction. So beekeepers could collect wild colonies using bait hives or catching swarms in the forest. But I think in Europe we can pretty much neglect this variable because beekeepers here usually don't do that. So it's rather an exception, let's say. And then obviously what also affects the fate of the wild subpopulation is the survival rate and the number of swarms produced by the colonies that are already members of that group. And the swarming rate is not so easy to observe in a natural study setting. So what we assumed for our study is that on average, colonies in Europe would produce 2 swarms per colony per year. So range from 0 to 4, but on average, like 1 prime swarm and 1 after swarm. And this is what studies found that specifically looked at the reproduction of colonies that were undisturbed and that were living in small hives. So yeah, if we assume this kind of reproductive rate, what is left to investigate is the survival rate of the colonies, and this can be done by repeated visits of known nest sites. yeah, such kind of study before we did our study in Germany. This kind of study was only done by Seeley in the Arnott Forest population and by Benjamin Oldroyd in Australia. And both studies really showed that there are self-sustaining wild populations in these areas outside the bee's natural range. Our study system was these black woodpecker cavities in managed forests. We had 3 study areas: Schwaben Alb, the north of Bavaria, and near the Alps in the south of Bavaria. And yeah, we monitored up to 450 cavity trees for up to 4 years. And in total, we were able to follow the fate of 112 colonies. The monitoring procedure was like this. So here's the months of the year with the overwintering season from October to March, and the swarming season in May and June mainly. In July, after the swarming season, we looked at as much trees as possible. Then the trees that were occupied by bees were visited again before the winter to see what's the summer survival. The occupied trees were visited again after winter in early April to see what's the winter survival, and then from April to July we would have the spring survival. We also did some maternity testing to estimate the rate at which occupied tree here would be lost, or the colony would die, and then the tree would be reoccupied. And yeah, these are the results of the monitoring for the 2 areas where we looked at many trees, like the Schwaben Alb and Coburg and Lichtenfels, over the 4 years. And in the upper panel, you see the data as percentage of trees occupied by bees. And the lower panel just shows the same data, but translated into number of colonies per square kilometer. Yeah, and the results show that when we go to the forest in summer and autumn, there are always bees. And the average over years and study region is about 10%. So in summer, I always expect around 10% of the woodpecker cavities to be occupied. But then in the winter seasons, the populations reliably crash. Put it differently, we have an annual survival rate of only about 10%. So 1 out of 10 colonies survives the year. This is an average colony lifespan of a bit more than half a year only. And a number that is very interesting for the statistics is the net reproductive rate. It's an index that says how does the population change from year to year without migration. So, and if the index is at 1 or above 1, the population is stable or even expanding. And if it's below 1, it is in decline. And our R naught is at 0.3, so the population is clearly in decline. What we can also look at is the number of swarms that the surviving colonies would need to produce for the population to be stable on its own. And it's 8 to 9 swarms per colony in spring. So it's really much higher than the assumed average of 2 swarms that are possible biologically, so to say. And from these data, we can also conclude that every year, 70% of the bees we find in the forest are recent immigrants, that is, escapees that recently came from apiaries. We can say that because when we go back to the forest in summer, we actually found that 100% of the trees, like 10% of the trees were occupied again. And so the population actually bounced back, but it's not, it's mostly because of immigration. And yeah, a brief comparison with the data from the Arnott Forest in the USA and Wipperfield National Park in Australia. So annual survival rate here, we have 11%. And interestingly, in these populations, there was a difference between founder colonies in the first year, only like 24% survival, 32% survival, and colonies that were established that already had survived one winter. That's almost, 79%, 76%. On average, perhaps we can say 50% survival rate annually, so maybe 5 times higher than Germany. And what I also find an interesting number is the average lifespan of colonies. I mentioned earlier, not every colony has to be immortal for the population to be stable. We here see that in these healthy populations, colonies on average also only live 1.5 years. So the study I presented was from managed forests, a very specific study system, black woodpecker cavities. But the study I mentioned earlier, the citizen science study, also used data to model the annual survival rate of colonies in other habitats in Germany. Here's our data. I presented German forests, and then 2 other studies conducted in cities in Munich and Dortmund. And interestingly, they found very similar survival rates of only a bit above 10% annual survival rate. And then the comparison to the data generated by all the citizen scientists, it seems the survival is much better, but the authors, they really nicely show that this sadly is a bit of a bias. So many of the citizen scientists only looked at winter survival a bit too late in the season when the swarming had already begun. So they often reported a winter survival when it was probably just a new swarm that went to the same cavity. For all who use citizen science data, that's just something you have to consider to have clean data, so to say. So for Germany, we can say the wild living colonies do not form self-sustaining populations. Of course, this is a bit frustrating. And then you could ask, is it really important that they're self-sustaining so we can consider them real wild populations? Interestingly, this is actually maybe a bit of a too stringent criterion. Benjamin and I were very lucky to be invited by Arrigo and Steve from Honeybee Watch to join the team of assessors for the red list status of Apis mellifera. So the IUCN, the International Union for the Conservation of Nature, they produce these red lists to see what is the conservation status of wild species. And the European red lists of bees needs to be renewed. And when we had this task of seeing what of the data we have can we use to make a real assessment, because in the last version of the red list, the honeybee was data deficient in the wild. So can we use any of the data generated in the last decade to make a better assessment? And then we found this definition by the IUCN of what can be considered a wild population. And it's a bit of a different definition. So what they say is the following: subpopulations dependent on direct intervention are not considered wild if they would go extinct within 10 years without intensive management, such as regularly supplementing the population from captive stock to prevent imminent extinction. So what does that mean for our case? So this in human intervention, we could say in our case, or this regularly supplementing the population is the process of swarms escaping from apiaries and, so to say, filling up the wild living subpopulation. So what we need to ask in our case, given the survival rates we observed in the bees, how would these populations change over a 10-year period without immigration? And would after 10 years, would some colonies be left, or would the populations be completely extinct? And only if they're completely extinct, they cannot be assessed by IUCN. They do not qualify as a wild population. Luckily, um, when we did this last year, there were already several other monitoring studies on the way, and there were some people that could provide us with fresh data on colony survival rates from other countries. So here are the 7 countries where we got data from. It's Southern England, Oliver Weissig, data from Luxembourg from a monitoring study, data from France, our own data from north of Spain, data from northern Poland, and then from the 2 cities in Germany that I just mentioned, besides our forest study, and data from northern Switzerland. And these are the results. So we use the survival rate data to project the autonomous population changes of these wild living subpopulations over 10 years. And in yellow, you see the 3 studies from Germany. Populations would completely go extinct in 3 to 5 years without immigration. And the data from Switzerland, interestingly, totally align with the German data. It's the same. But on the other hand, the wild living colonies in Spain, in Poland, in France, and Luxembourg, they would not completely go extinct in 10 years. And so they qualify to be considered wild populations according to IUCN criteria. And the population that gives a lot of hope is the one studied by Ollie in England. This population is apparently self-sustaining and even has the capacity to increase. Here, another way of showing the data, so the percent change after the 10 years, and the median for the whole of Europe. And on the right side, you see the IUCN conservation category, it's least concern, then 3 types of endangerment: vulnerable, endangered, and critically endangered. And when we use these methods according to the IUCN procedures, we see that the wild living colonies in Europe would decline by 56% within 10 years. This means they can be classified as endangered, actually. And yeah, I'm pretty lucky that our group of assessors was accepted this kind of method to assess the population status. And it seems that in the next version of the European Register of Bees, Apis mellifera will change the conservation category from data deficient to endangered. So this was the level 2, the level of the population demography. When we see the high mortality of wild living colonies in Germany and Switzerland, there's the obvious question, why? So how can it be explained by environmental factors? Is it lack of food? Is it lack of suitable nest sites? Is it parasite pressure, varroa and the viruses? We have a preliminary study, so to say, on this based on the observations we made in the forest study system. But even if we know more about the environmental factors, we would always have to ask, do intrinsic factors also play a role? So are the bees affected by our long-standing culture of bee breeding in the German-speaking countries? Do the bees we have in our countries actually have they lost some traits that are needed to survive in the wild? Or is it the introduction of honeybees from other regions, even other honeybee subspecies that are not adapted to the local conditions? And this brings us to the 3rd level of wildness in honeybees, which is asking for the evolutionary history. So a hardliner, so to say, or when you're very strict, you can say honeybees are only wild if they don't have any genomic signatures of past selection under beekeeping management. So the leading question here is actually, do populations of wild living colonies exhibit such genetic adaptations to modern apiculture that maybe come with some costs for their life in the wild? And what this question actually refers to is the big question, so to say, are the colonies we have in apicultural management, are they actually under domestication? And to discuss this, I would like to show a quote by Charles Darwin from his book on domesticated animals. And he says that bees have been domesticated from an ancient period. But then he questions this first part of the sentence, if indeed their state can be considered one of domestication. For they search for their own food, with the exception of a little generally given to them during the winter. Their habitation is a hive instead of a hole in a tree. So I would say in the first sentence he's actually a bit imprecise. So bees have been managed from an ancient period would be more correctly. And yeah, he also questioned if the state of the honeybees can be compared to other livestock animals that are clearly domesticated. And I think the last sentence actually says, well, the main difference probably is that the bees live in an artificial box and not in a hole in a tree. It's also interesting to look at definition of what is domestication. And here, what is important to highlight is that domestication in the narrow sense is considered an adaptive evolutionary process in which humans obtain services from a partner species that domesticate through modification of the domesticate's environment, and the domesticate evolves towards increased fitness and increased provision rate of the service within the modified environment. It's very technical, but the nice thing of this definition is that we do not need artificial conscious selection by humans for domestication to be underway. And there can also be unconscious selection in the human management setting. So there are many environmental manipulations we have in the modern apicultural systems, and there might be many factors that affect the bees and yeah, make the bees adapt to these situations which are without us actually be conscious about. And yeah, when thinking about domestication, we can also think about some arguments against it and for it. So arguments against domestication is that beekeepers have limited mating control over honeybee queens. And as we saw in the first part of the talk, level 1, there probably always have been wild colonies in the population. So the queens would always also mate with drones from wild colonies. Then I think a good argument is that what we depend on in apiculture is mainly the great behavior of the bees to be able to forage so efficiently and harvest surplus nectar. And this behavior was optimized by the bees even before we started managing them. So no much need for domestication actually. And another argument is that every beekeeper knows that when you leave the bees alone in spring, they will quickly revert to a natural state. Again, level 1, they will swarm, they will choose a cavity and build a natural nest somewhere. Of course, since we have the movable frame hive, since we are able to feed artificial sugar, since we apply medical treatments, we're strongly modifying the environment of the bees. This can have an evolutionary response, so to say. mating control is partly possible at isolated mating yards and when using instrumental insemination. Here the question is rather, how important is this? Or like, how do these practices affect the overall population? And then there are some breeding programs that have evidence of really changes in the desired characteristics. This is an example of the Carnica, Apis mellifera carnica breeding population from Germany and other countries in Central Europe. Several traits that are relevant for the bee breeders. And we see here the average breeding values. And from 2000, maybe 2005, you really see that the bees really get better in all these traits due to new techniques and methods of how to choose the queens and drones to mate with. And this is really evidence for a direct change for domestication in this specific population. Okay, I will skip this. When we talk about domestication in honeybees, we have to consider that there are other types of genetic changes that happen under management and that we need to distinguish from domestication. This is shown by this slide. So consider the bees under wild conditions and any trait. For example, like the egg laying rate of the queen. So there's this trait and there's probably an optimum and there's a selection pressure here indicated by the arrows. So it should stay in this range. What beekeepers have always done, since it's possible, they have introduced bees from other regions. And they introduce this population here in the darker color, and they have a different optimum. And the bees, the foreign and the local bees, they will mix, and you have a hybrid population. And here the trait perhaps will be like intermediate. So this is a change compared to the original population that has nothing to do with breeding. It's just the influence of another natural population that was brought to the place. This is very, very common. So there might be differences between the managed population and the feral population. Here, in this case, they're called feral because it's Australia. And the composition of ancestry. So this part shows the proportional ancestry of dark European honeybees from Western Europe, Apis mellifera, and the yellow part shows the heritage of Apis mellifera ligustica and Apis mellifera carnica. And here's a clear difference, but this does not mean that this difference is really functional. This can be readily explained by the dark bees were brought to Australia first by the English settlers. And it was only later that beekeepers started to like the Apis mellifera ligustica and carnica subspecies. Another typical process is random propagation. So imagine you start an apiary, you get one colony, and you're really ambitious. You want to make a big apiary or like increase your stock. And with a movable frame hive system, it's possible to create many colonies artificially. And what you would do is you create a genetic bottleneck, which leads to genetic drift, and you randomly make a small selection of the original population, and you change the optimum a little randomly, and you also reduce the genetic diversity. So this is probably a very common process in apiculture, but this is not domestication. Well, another process that is common in apiculture is like the lack of selection pressure. Imagine, for example, the need for the bees to be adjusted to the local phenology of flowering plants. If we can feed the bees before they starve, this need to be perfectly aligned with the flowers is gone. So there's a lack of the selection pressure. Also, if you consider varroa mite as a new natural selection pressure, treating its varroa is removing the selection pressure. And this actually leads to a large diversity in the managed population, but it leads to the accumulation of variants that under natural condition that would be selected against again. And then there's domestication proper, so to say, which can be due to artificial selection, can also be due to unconscious directional selection. For example, think of a gentleness or a high egg-laying rate, which is specifically selected, and you have a directed change in the trait in the managed population. So in my current study, it's a collaborative study. We are looking at exactly this. We want to quantify, are there genomic signatures of modern apiculture? And if so, how much of the genome is affected? We would like to quantify it. And this is a bit challenging. What we need to find is true wild populations that we can compare the managed bees to. And in this case, true wild really means populations that are self-sustaining, that we know that they function well under the wild conditions. So there's reason to assume, they have their genetics fits the wild environment, so to say. And we compare these populations to managed populations from the same area. And what we then do is we have to account for genetic differences that are just a result of a trait of different subspecies. So imagine the wild colonies are Apis mellifera mellifera, and the managed colonies are mainly Apis mellifera carnica. This carnica is not generally less wild than mellifera. It's just a different subspecies. So this we need to account for. And we need to distinguish genetic differences resulting from random processes like genetic drift from adaptive processes. And here is how this is possible. So you need to look at several populations, several independent populations, to factor out the random differences. Imagine we have a wild and a managed population in region 1, and these are their gene pools, and you see like a considerable amount of diversity that is only present in the wild and the managed population, respectively. But when you consider the genomes of the populations from a different region, you might find this pattern, and you see what we're really interested are these fractions. So the fractions that are only shared by the wild ones, only by the managed ones. Imagine we consider, let's say, 10 regions, and you can imagine that these areas get smaller and smaller. And really the question is, will there be anything left? Is there any genetic variation that can distinguish wild and managed colonies generally? And what we did in the last year is to collect paired samples of such wild and managed populations. We got bees from about 15 regions worldwide, and we will look at them using whole genome sequencing to identify single nucleotide polymorphisms, so these variable parts of the genome. We will also use available reference data for the different subspecies, so we can assign every population like a proportional subspecies ancestry, and to factor out this effect. And in the end, we try to identify and quantify genetic regions that differ consistently between wild and managed populations. So we're trying to answer these questions of how domesticated are managed colonies, honeybees, on this global perspective. This is a kind of evidence for collecting here with Ollie Weissig in England. at the wild and managed colonies, another impression from Western Australia. Yeah, to summarize this analysis of the different levels of wildness, I have this table here, and I just want to highlight that I think that the level of the population demography is the most important and most important for applied conservation purposes. For example, if we consider why is it actually interesting to investigate and conserve wild honeybee populations, I would say there are two main reasons. There are ecological interactions of wild honeybees. As the pollination of wild plants in forests, for example, like these bees would be much less frequent in the forest if there were no wild living colonies. And there are also these interesting interactions at nests, so wild honeybee nests as a resource for other species. And these services, so to say, by the wild honeybees, they are maybe already fulfilled by just wild living colonies that escaped from management, although it's a question of abundance. For example, you won't have bees pollinating spring flower plants by bees that do not have a self-sustaining populations because there will be few colonies in the forest in spring after winter. And then there's the idea of that wild honeybees can be a genetic resource. On the one hand, they can provide locally adapted honeybees for a sustainable future beekeeping system. And of course, this only works when you have a self-sustaining population. Otherwise, the bees you find in the wild are just essentially a fraction of the diversity you already have in the managed population. And there's also the potential that in case the native subspecies are better adapted to the region, that promoting wild colonies also increases the frequency of the genes of the native bees in the population. So yeah, here it's really important to consider the population level, whether the wild living colonies form self-sustaining populations. Yeah, and in the end, I would like to highlight that there are different dimensions on which to describe honeybees. Are they wild living or managed? You can also talk about management intensity, maybe. Are they native or non-native on the species level? You can also look at the subspecies level. What about population status? Is the population self-sustaining? Can also look at the level of intraspecific hybridization. So is it a pure Apis mellifera mellifera, or is it a hybrid of several subspecies? And the question most difficult to answer, are there any signatures of selection under beekeeping management or past beekeeping management? And yeah, just to show you, with these variables, you can describe different populations of honeybees and in different ways. And important to notice that the question of wildness on the colony level, is the colony wild living or managed, is independent of these other dimensions of whether there's evolutionary signatures of domestication, whether the bees are native or not, and so on. As a concluding slide, what are the preliminary conclusions regarding the levels of wildness? On the colony level, we can clearly distinguish wild living from managed colonies. I think it would be common sense to say that the self-sustaining populations of free living colonies can be considered truly wild, even if for the IUCN it's even less stringent. And one important note that when you consider the evolutionary history, virtually every bee queen we have in Europe will have recent ancestry that lived under beekeeping management. But management is not equal to domestication. And as we have limited knowledge, limited evidence of genomic signatures of apiculture, I think that any subpopulation of free living colonies should be considered potentially wild. So the principle of in dubio pro reo, if we don't have enough evidence, then we should plead for non-guilty, so to say, when honeybees are accused not being wild. Yeah, with this, I would like to thank my main collaborator, Benjamin, and the funding agencies of our projects and all the people that made these investigations possible, especially the researchers that provided these early data on colony survival rates from different regions to make this assessment of population status. Yeah, and I thank you for your attention.
Thank you very much, Patrick. Great lecture. I think there we have two very important milestones, which are new, in my opinion, for the public in general. So I'm very glad that you separated the word domesticated from managed, a work we are discussing for quite a long time and really great. And the new status, I hope it will be like this from the IUCN. So very, very great milestones. So let's open the questions. Who would like to ask a question? Just open your microphone and ask whatever you would like to ask. Really no one? Probably I come just up with some kind of a progressive thought. I mean, I've always looked as we try as humans, we try to separate whatever we can separate. So we try to separate in races, we try to separate in managed, in wild, feral, whatever. But if I look in a little bit easier way, I just see one species, Apis mellifera, and I come to the conclusion that somehow we manage the wild species. And so why not think of just one single population and without trying to separate the apiculture from the wild living honeybees?
Yeah, this is tempting, but I would say we make it too easy. So if we just put nest boxes and see they will be occupied every year, we put perfect settler cavities, the bees are flying every year, and we say this is fine, then yeah, we're missing out on the potential that a self-sustaining wild population can have. So of course, if you the nice so if you do this to promote just the proportion of wild living colonies, of course there's a chance that the selection pressures under these wild conditions become more important for the whole population, right? And then help the whole population to become more resilient, so to say. So this is a nice method. It's a nice way of thinking. Yeah, but I think that you should always have the goal in mind that something should be able to change for the bees.
Sure,
right?
Sure.
But especially as we looked at the situation in Germany and Switzerland, probably what you're doing right now is the best we can do at the moment, no? So to really, yeah. Also, already just talking about this possibility of honeybee wildlife, wild living colonies, the awareness that you maybe don't have to remove every colony, you don't have to save every colony that
Sure.
you find, and even providing these nest boxes, yeah, I think it's a good way, and especially it's a nice way of having material to monitor colonies and to see are there changes. And I would really like to encourage everyone to do such population monitoring because from now on we will probably need such new data every kind of decade to assess the population status again. It would be super interesting if something changes and then to see maybe why.
I completely agree. And I mean, it's really interesting your graphics that in Germany, Switzerland, bees live in a completely different way than in many other countries. And I mean, if you go to England, to Wales especially, you have plenty of reasoning why things are better for bees over there. But when it comes to Luxembourg, Holland, I guess Holland, you would find similar good data. So there is not really an explanation anymore for the difference to Germany and Switzerland. And this would be another very interesting theme to make studies on this one.
Yeah. Yeah, this rather points to the importance of the intrinsic factors, right?
Yeah.
To the genetics of the bees, because in German-speaking countries, people have been very rigorous in breeding bees, and the beekeepers are just so well organized. It's yeah, just the fact that, for example, in England, you don't need to register your hives. So the honeybee is not a veterinary case in England. This makes a total difference. So,
Completely agree. I have the same hypothesis.
yeah.
Oh, let's open once again the questions. I have certainly some interesting questions too. Okay, if there are no other questions,
I have a question.
Okay.
Okay. But I'm not quite sure if I can have it in the right way, right thinking way. So what I thought about, I wrote about some studies that made in Scandinavia, I guess, on islands, where a huge amount of colonies were there, just get feeded and let the varroa parasites do what they do and just see what the result is. And after several years, they really tried to stop it because almost every colony died. But then it's there were a point where it gets stable and then um, um, increase after some years. And the study you showed us showed that Luxembourg and Switzerland would extinct in 10 years completely. What is the difference in these two studies that they say, okay, in Germany they will really every probably will extinct and in others not? And maybe question B, are there in Europe even some regions where are no effect of beekeepers? So they are really a safe area where we can really be sure, okay, this will be wild living honeybees.
Yeah. So you refer to the Gotland experiment in Big Island of Sweden. There, the situation is the following. They really had this isolated population to make the experiment. So what's happening there is really evolution. So the only colonies that somehow can resist the varroa mite or live with it survive, and then the population increases again. This is what we expect to happen in most regions where you have certain level of genetic diversity. The demographic studies we showed, you have to look at them completely different because it's just statistics. So it's looking at wild living colonies in a matrix of managed colonies. How do the colonies in Luxembourg and Germany and Switzerland, what's their survival chances right now on average? And then let's do the thought experiment. Imagine there's no beekeepers, no swarms that can go into the wild population. How would these populations, just due to their survival rate, how would they change over time? Would they be stable? Would they go up? Would they go down? So there's always immigration of swarms. So we cannot just observe the number of colonies. As I showed you in the monitoring study, when you look at the bees in the forest in summer, it's like stable. It seems to be stable. There's always similar number of trees occupied. But when you make the calculations, okay, based on their survival, how would the population decline? Then you see what actually is happening is that they always go extinct, but there's a turnover of colonies. So under this model is completely without any evolution happening. It's just the current survival chances. How would these survival chances translate into population growth or population decline? So of course, if we let all the colonies in Germany without treatment, we would expect that the population drops, but there will certainly be many colonies that somehow survive, especially under wild conditions where the varroa pressure is even a bit lower. And yeah, at some point it will probably go up again, and there was selection. And yeah, does that answer the first question?
Yeah, I guess, yeah.
Okay, and the second was again.
Are there really
Are there isolated populations? Not really. So beekeeping is probably happening everywhere. It depends on the scale. And this is also a big question. How big does the area need to be for evolution to happen? So actually, we do not know what's the relevant spatial scale. So for example, in the study system in England, I visited Ollie to collect the bees, and they have these landscape parks. When you are in the middle of such a landscape parks, it's until the horizon, so it's maybe several square kilometers, but it's not really huge. And then they have many old trees, and then you have maybe 20 colonies, 20 wild colonies together in this park. And this already seems to be sufficient. So visiting his study system really changed my mind completely. I thought, there are just too many managed colonies. We don't have these big spaces, but maybe it's actually possible on smaller scales. Yeah.
Okay, thank you.
You're
Thank you.
welcome.
One last question.
I have a question.
Sure.
Is it possible that in Switzerland and in Germany that we have too high density of colonies, so that the colonies does not have enough food for the winter, and that this is the reason why they die?
Very good hypothesis. Yeah. So I think this is one of the main reasons for the high mortality. And it's an important factor that there's actually competition among the honeybee colonies. No? And we know this when we catch a swarm and put it into our hive, beekeepers would always feed it, right? If you don't feed it, like your colleagues would say, yeah, why didn't you feed it? Obviously they die. No, I mean, and so they really face the challenge of collecting enough food in the first couple of weeks. So this is the main effect. Yeah, and it's actually interesting. We have a highly intensified agricultural landscape, and we still have quite many honeybee colonies managed because it's a cultural thing, right? Maybe, yeah, it would be interesting to analyze whether the amount of the nectar availability, the relative availability is different in different study areas. Yeah. These are highly populated countries, right?
Okay, then. Thank you. Thank you, Patrick. Great lecture. Thank you for your
Thank you.
time. And thank you to everyone for your time and your interest. And a big thank you to all the donators and workers for making it possible that we can have such lectures once a month. And you will find on our website, freethebees.ch, the new lectures coming for the next month and the recordings of all the past lectures. You can find them on our YouTube channel on FreeTheBees Switzerland. So thank you and have a good evening, have a good night. See you. Bye-bye.